They knew where I was.
Okay, good morning. We started talking about basic arithmetics. I want to give you these problems, give you approximately 40 minutes to think about and work them out, and then we come back and discuss together how to solve the problems if you have some difficulties there. Okay? But you are not allowed to use the calculator, but it is instructive later that if you have your laptops available, after you solve, check your answer using GeoGebra, so to improve your skills how to use the app, okay? But for the time being, you just try to solve them without calculators. Of course, I don't know how much you remember about these things. I intentionally made the numbers a little bit bigger so that if you get a stock, I can give you a systematic way to do these things. Of course, if you want to do things by hand, it will take more time. Okay, so I just give you 40 minutes, and please do not disturb others. You can talk together. It's always instructive if you consult together, but not from the beginning. It's better you yourself think about the problem first wisely, and if you get a stock, then you can talk to your peers next to you, but very slowly, so that if someone wants to work privately, you shouldn't disturb that person. Okay? Thank you. Okay, so I don't know how many of you succeeded to solve the first one. I agree with you because you are very used to use the calculator here. And I intentionally gave the numbers among not very, very famous numbers. So I don't know how many of you could manage to find the least common multiple, or what you say, least common denominator. What that is?
72.
72. Okay, so 72 itself is divisible by 24, and it's also divisible by 36, and needless to say, it's also divisible by itself. And it is clear that you cannot find some number smaller than 72 with these properties, because then it will not be divisible by 72 itself. Is that clear? But of course, the question is that how, if I couldn't guess, then how can I find this systematically, that the number is 72? Okay, so I want to teach you this, and I want you to communicate with me to refresh your memory, because I think many of these things that I'm going to tell now you already know. Might be you have forgotten. Okay, the first thing that I want you to define for me. Do you know a prime number? What it is?
2.
No, the definition of a prime number. Yes, and what is your name, please, so that I can try to remember? Yes. Ali?
Zari.
Zari. Okay. So
Prime number is only divisible by 1 and itself.
Okay, for example, the square root of 2 is a prime number or not?
Yes. I think.
Yeah. So I mean, you are right. I understand what you mean. Your definition is 99% perfect. But in mathematics, you need to learn to talk very precisely. I mean, with 100% precision. So you should say that a prime number is a natural number. You know the natural number, yes? 1, 2, 3, 4, etc. It's a natural number, yes? Because how many type of numbers we have? The most natural one is the set of natural numbers, yes? Let me just a little bit introduce this to you. So in mathematics, this natural number, we denote it by n, but because these are very famous ingredients of mathematics, we also put a line next to it. So whenever you see this symbol, it doesn't just mean n, it means the set of natural numbers. And then if you want to specify a set, you have to use, this is the punctuation rules in mathematics. You do not use brackets, you do not use square brackets, you have to use curly brackets. Exactly like that, when at the end of a sentence, you don't put comma, it's common that you put full stop. Yes, that's the same story. So this is the way that we do it. And then the numbers 1, and then you separate the numbers by comma, and 3, 4, etc., etc. So that is this, and then you close it by another curly bracket. So this is the set of natural numbers. Okay? Now among these numbers, now what you said is correct. If you look in this set, the numbers that are divisible only divisible by 1 and divisible by themselves, they are called prime numbers. Yes? Because every number is of course divisible by 1, every number is of course divisible by itself, but it might happen that that number is also divisible by something else. That number is not a prime number. Not a prime number in mathematics is called a composite number. Okay? Composite means not prime. Okay, so for example, if I want to list some of the prime numbers, what is the first prime number that you can tell me?
1.
Okay, that's also a good question. 1 is not a prime number, even though it seems that it satisfies the definition to be a prime. Because 1 is only divisible by 1 and by itself, which is again 1. But mathematician has chosen to exclude 1 from being a prime. I will talk about that why. So by convention, 1 is not a prime. So you might say that if it is not a prime, it's a composite number. No. 1 is neither composite nor prime by convention. Yes, so the first one, so remember this was an important thing that I told you. 1 is neither composite nor prime, yes? But the first one is 2. And the next one is 3. So why 3 is a prime number? Because the only number that 3 is divisible by is 1 and 3 itself, yes? And then the next one is 5, the next one 7, 11, 13. For example, if you list them 23, 29, and then you can continue this list. Okay? So if you look at this list, there is one exceptional number in this list, and that is 9. No, 9 is not here. Because why 9 is not prime? Why? Because 9 is also divisible by 3, yes? But one of these numbers is different from others. 2. Why is that? It's even. Can you imagine that this is the only even number in your list? It's easy for you to give an argument to me. Why 2 is the only prime number and even number?
Because if it was any other, you could divide it by 2.
By 2 at least. So for example, 4, 6, every even number is at least divisible by 2. So it is not only divisible by 1 by itself, but definitely it is at least divisible by 2. So it violates the definition of a prime number. So this is exceptional. This is the only prime number which is even in our list. Every other prime number is odd, but not vice versa. Can I say every odd number is also a prime number? No. For example, as you mentioned, 9. 9 is an odd number which is not a prime number. Yes? So it's very important to see that this direction, every prime number larger than 2 is odd, but there is no guarantee that every odd number larger than 2 is prime. Be careful about it. Okay? And then, mathematicians, by the way, this is a topic of active mathematical research. So far, we haven't found a formula that generates all prime numbers. If you can't do that, probably you will get $1 million US dollars for that, if you can't generate a formula. And I don't want to talk about prime numbers that much, but I just wanted to introduce, I want to introduce this to you. So you see, it's not organized. So the difference here is 2, the difference here is 2, suddenly the difference is 4, then the difference is 2, 4, and then suddenly 6 and 6. So there are no very generic rules how to generate them. So this is very important to know. But this is also something which was not very clear, it's not very obvious. Do you think this list is finite or it contains infinitely many numbers? This is not obvious at all, because when you go forward, the chances that you have a number which is not divisible by any previous number becomes smaller intuitively, yes? But this is not the case. Actually, Euclid, 400 BC or 300 BC, was able to give a very beautiful argument for this, that the list of prime numbers continues forever, even though we don't know the rule and pattern. We haven't discovered the pattern, so there are infinitely many of them. Remember these facts about the prime number. Why prime numbers are so important? Do you know why? There is a reason why we care about prime numbers so much. Yes?
Because it breaks down numbers to their constituent elements.
I would say 90%. So can you give me an example to understand you better?
For example, with prime numbers, you can break any number you have, no matter how big it is, down to one number by like dividing and dividing and dividing. You will at one point reach a prime number.
Yeah, I would say it's correct, but I mean that every number, every natural number can be written as a product of only prime numbers. And that's the reason why prime numbers are so important. So they are actually building blocks of numbers. So for example, if a number is prime, okay, it's already a prime. Okay, but if a number is not prime, say for example 6. 6 is not a prime, but can be written as a product of prime numbers. Always. What are those numbers? 2 and 3. If I want to keep the order. Order math doesn't matter, but let us be organized. Okay, but let us consider, for example, 27, or let me just write 24. So, how can I write this as a product of only prime numbers? I can write it as 3 times 8. 3 is prime, but 8 is not prime. But this is possible always. This is very important. Always, without exception. That you can write this as a product of only prime numbers. So, what are those numbers? 2, and again 2, and again 2, and then 3. So if you multiply them, it becomes 24, and all of these numbers are prime numbers. So I was able to write 24 as a product of only prime numbers. Yes? So of course, you know that it is a little bit easier for us to use the exponent notation. Instead of writing 2 by itself 3 times, it would be better to write 2 to the power of 3 times. Okay, now not only this, it is more or less unique. So it means that if your friend does the same thing, he will definitely get the same. Might be the order of these factors are different. So might be your friend write like this. Yes? But the numbers that he's using are 2 and 3. 3 is repeating 1 times as mine, and 2 is again repeating as 3 times. So every number can be written uniquely if you don't consider the order as a product of prime numbers. Now you understand why mathematician has chosen to exclude 1 from being a prime. Can you tell me why?
We just write it over and over.
Yeah. And the uniqueness we will lose. Yes? So it means that if I put this as a prime number, in principle I should say that 1 is a prime number because it's only divisible by 1 in itself. But why I exclude it? Because in that case, 20, for example, consider 6. I might write it like this. Your friend might write it like this. Okay, so order doesn't matter. But another person comes in and write it like this. If I consider 1 to be prime, that's also acceptable. Another person can come write this. Yes? And then what happens? Then it would be a mess. In mathematics, whenever something is unique, it is better to keep that unique because we can talk about the factorization of a number. Otherwise, I have to say a factorization of a number. In exam, I should say find a factorization, and your answers could be quite different, and all of them be correct. So whenever in mathematics you can pinpoint something uniquely, it's better to do that. So you don't lose that much if you exclude 1 from the prime numbers, what you gain in return is that you gain uniqueness in factorization of a number to any product of prime numbers. Yes, is that understandable? So even though that's a convention, but there is a reason behind why we use that convention. Okay, so this is something that you know. This is, by the way, this is the power of mathematics. This is only for mathematics. It means that until the end of this universe, this statement will remain intact. You will not ever find an exception for it. That is a really, really important power of mathematics. For example, if you consider Newton actually discovered some laws of nature. The Newton's, I don't know how much you know about physics. So have you heard about Newton's law of gravitation, for example? So he found a formula for how two bodies interact gravitationally. And then it was not 100% correct. Then later, Albert Einstein actually modified the theory to a more generic one. And then you know that if Einstein's theory was not there, we didn't have any GPS. So GPS is not possible to be calculated using Newton's model for the universe. You have to use Einsteinian model for the universe to be able to have the GPS. If you want to use the Newtonian model, then probably if you want to reach to this school, you will end up 10 kilometers away, okay, which is useless. Okay, so I mean that in physics, things might change. But if you have a statement in mathematics, this will live forever. Because that's exactly like, think about this. Do you think in the future, by the advance of technology, one day you cannot play chess? No. As soon as you have the board and the pieces and know the rule, you will be able to play the game. It might be a boring game at that time. I'm not saying that, excluding that. But I mean, you can still play the game without any contradiction. If you know the rules, you can still play the game. It might be the game is so boring, so useless. It's correct. But still you can play. So the only thing that mathematics cannot tolerate is self-inconsistency. If you say something and then you also say the negation, the opposite exactly of that thing, if something like this happens in a structure of mathematics, all mathematics will collapse actually. So if you want to get rid of the exams in mathematics, try to find a contradiction in mathematics. By the way, this is a little bit deeper than that. We can talk a bit later. Things are not that simple. Okay. Now I want to give you a little bit systematic method to do this factorization. By the way, when I want to ask you to do this in exam, it might be a question. I give you a number and I ask you in two different ways. I can ask you factorize the number into prime factors, or I can ask you to write the number as a product of only prime numbers. So these are the different types of questions that I can ask. And if the numbers are simple, be my guest, guess them. But if the number is a little bit bigger, you need a little bit systematic way to do that. For example, let us go back to those numbers, 36, 24, and 72 in the denominator. Yes? For example, take 36. What I do, I am a little bit old man, so I use the traditional way. I saw in the book, they have done it in a little bit different way. But I think I always pay attention to do things fast. Okay? It's important. So what I do, I write my number 36, I draw a vertical line, and then I start writing a prime number. It's important. A prime number on the right so that the left-hand side number is divisible by that prime number. It doesn't matter which one you choose. The simplest one that I can choose is what? Because I know 36 is even, so it is definitely divisible by 2. 2 is one of the prime numbers, acceptable. If you don't like it, you can put 3 here. Because 36 is also divisible by 3, and 3 is prime. Can I put 5 there?
No.
No, even though 5 is in my list, but 36 is not divisible by 5. So let us pick one. I choose the simplest one, 2. And do the division, either using your calculator if the number is so big, or using your head. So it's not hard. And my impression is that when you think about money, your brain works better. So if you have 36 crowns and you want to keep it, split it in 2, you will really immediately understand. I don't know why, but this is human nature.
Money is power.
Yeah, probably. So this becomes what? 18 crowns, okay? And then repeat the process. Mathematicians have proven that no matter how big this number is, you will end up with 1 every time at some point. And that process is finished there. It is not trivial, by the way, at all. you need to have an argument to guarantee that from the time of discovery to the end of the time and universe, this will be the same. No matter how hard you work, you will not find an example ruling this out. Okay, so what is the next process?
9.
9 is not acceptable. 9 is not prime. You are not allowed to put 9 here. Only prime numbers, yes? 3. Or can I use 2 again?
Yeah.
So let us use 2 again. You can put 3. And then it becomes 9. And then
3.
3. 3. And then 3. And then you end up with 1. You divide. And this happens all the time, no matter what is the nature of the number. And then what happens, you multiply them together, you will get this number back. 2 times 2, 4 times 3, 12 times 3, 36, so that's correct. So what you write 36 is equal 2 times 2, which you can write 2 to power 2, and then you can write 3 times 3, which is 3 to power 2. So I wrote 36 as a product of only prime numbers, 2 times 2 times 3 times 3, so I wrote it in a shorthand way in this form. So this is called factorization of 36 to prime factors. Yes? And I do the same thing for 24, so let us just do it together once more. So this is 2 again, do you agree? This is 12, 2, 6, 2, 3, 3, again 1. The process is finalized. And then I multiply them. So let me write them here. 24 is equal to 2, 2, 2, 2 to power 3, and then 3. And finally, let me just do the last one, 72. Which one do you prefer? 2. What's the answer? 36, 2, 18, 2, 9, 3, 3, 3, 1. And then you write 72 is equal to 2 to power 3, 3 to power 2. Yes? So this is something that is in the book, and you have to know this. This is one thing. But what is the application in our problem that I brought this up? You can use this to find that number systematically. That number is called the greatest common divisor or denominator. The best word for it is divisor, which will serve as your common denominator as well. Okay, sorry. Very bad mistake from my side. It's called multiple. Okay, and then you write GCM for short. Greatest common multiple. So, greatest common multiple of these three numbers, I want you to discover it yourself, because if you discover it, you will not forget about it. I want a common multiple. Do you know what is a multiple? So let me ask you something, because these two words in English you need to know. So divisor, multiple. Okay, so let me ask you one question. If I give you 12 and I ask you to give me a divisor of 12, give me one example of a divisor. Yes, please? 6. Divisor means this number is supposed to be divisible by that number that you are telling. But if I ask you give me a multiple, what is the multiple?
24.
24. What is the smallest multiple of 12?
24.
No, the smallest multiple of 12, 12 itself. Yes? The smallest multiple of any number is the number itself. What is the smallest divisor of any number? 1. What is the smallest divisor? 1. What is the greatest divisor of any number? Itself. So let us just repeat it again. So divisor, when I say, so if I want to say here, 2 is a divisor because 12 is divisible. If I want to give a multiple, I can say 24 because 24 is divisible by 12. Multiple divisor. The smallest divisor is 1. The biggest divisor is the number itself. The smallest multiple is the number itself. But can you tell me what is the biggest multiple? There are no. Because 12 is a multiple, 24 is a multiple, 36 is a multiple, 48 is a multiple. You can make it as big as you want. So there is no end for the greatest multiple. Okay. Now I want you to tell me how can I find the greatest common multiple. So for example, when I say multiple, it should be divisible by 36. It should be common multiple. It should be divisible by 36, divisible by 24, divisible by 72. Okay, so let me write a number x. I am looking for it. Let me call this x. I want x so that when I divide x by 36, it is possible to divide. Yes? So if you have x here, you want to be able to divide x by this number. So this means that in x, you should have factor of 2, you should have a factor of 3. What is the minimum number of factors of 2 that you should have in x? 2, yes? Do you understand what I'm saying? Because, for example, if x is 5 times 7, do you think that 5 times 7 is divisible by this number? Is 5 times 7 divisible by this number? No, because 5 and 7, 5 is not divisible by 2, 7 is not divisible by 3. You can imagine immediately that this number is not divisible by this. So if you want to have a hope that what you write is divisible, it is clear that you have to have 2. You should have what? You should also have 3. Because otherwise it is not possible that this is divisible by this number. But can I have this factor of 1 here? No, because if this is 1, how many 2's are here? 2. One of them will be cancelled. 1, 2 will be left in the denominator, and it will not let you the number to be divisible. So it means that you have to have at least a 2. Yes, you have to have at least a 2. But can I have something extra here? Extra I can. Yes, because if I put extra numbers here, it is still divisible, but this is not the optimal one if you are taking. So I want you to understand this. Okay, now tell me, how can I do this here? I want my number be divisible by this. So it should contain factor of 2 and factor of 3. Yes, because that number is supposed to be divisible by 36. Okay, how many factors of 2 I need right now for only considering 36?
2.
At least 2. How many factors of 3 I need if I just consider 36?
2.
At least 2. So the factors should at least be 2. But if I put factor of 2 here, factor of 2 here, then I will have some problems for 24. Because 24 needs how many factors of 2? 3. So this means that, let me change it to 3. Okay, is 3 enough? Yes, because 3 factors of 2 is enough for this case, is enough for this case, as enough for this case. Yes or no?
Yes.
Okay, let me just repeat again. Is the second factor of 3 enough for all of them?
Yes.
How many factors of 3 are involved here? 2. How many here? 1. How many here? 2. So I don't need more than that. So I found my number systematically. And then if you multiply, this is how much is this number, everyone? Because some people still say 6. 8. 2 times 2 times 2. Yes, 8. And this is 8 times 9? 72. And that is the number some of you could guess. Yes, if you cannot guess, unfortunately you have to spend some time, but there is some systematic way to do it. So, if I want you to summarize what I said, can you give me a recipe to do that? I told you in this way because I want you to understand this is not a God-given rule. If you think, you will understand what to do. But after you understood, give me a recipe. I give you a bunch of numbers. By recipe, I mean that if you are good in coding, I don't know how many of you are good in writing programs in some language, Python or whatever. I really recommend you go home, and this is a very nice practice. Tell your program how to find the greatest common multiple of some numbers that you provide. Okay? So, now can you give me a recipe? I give you a bunch of numbers, and I ask you to systematically, algorithmically, tell me what to do to find the greatest common multiple. Step by step, yes?
Find the factors of said number.
All the numbers that I give you, you factorize them in that way, and then?
After factorization, find, let's say, how many pairs you get. So in this case, like how many, if it's two squared or three squared, how many of those you get, and then have that as the lowest, and everything that you need to either meet it or exceed it.
Okay, so that means that, so you choose the highest power.
Yes.
Yes, that's correct. So what you do after factorization, you write all possible prime numbers that you see in this list. Okay, all prime numbers, but you choose the highest exponent for that. Yes? So that is the way that you do it. Is that clear? So factorize the numbers, see how many prime numbers appear, write all of them in your list, and choose the highest exponent in your list. And then do the multiplication. That would be the greatest common multiple, which will serve here. Okay, let us finally, after this very long introduction, solve that problem. But be careful. The reason that I am explaining so much, because I want you to understand. I could have told you algorithmically, okay, do this. This is not good way of learning mathematics. You need to understand why. And then there will be two type of people. Some people will like these methods and they will continue. Some people actually just find a recipe. So I will give you both. I will tell you how to understand if you are that type of person who wants to understand, or how to find a recipe without understanding, do that. Okay? So, but let us go back and solve finally this problem. This was a very simple problem. I use this as an excuse to explain you a lot of things that you need to know. So 7 over 36 minus 5 over 24 minus 1 over 72. So what I do, I will write 72 here, minus sign, 72 here, minus sign, 72 here. I want to rescale it. Okay? I ask myself, 36 is rescaled to 72. How? By multiplying by 2. By the way, I can also understand it here. It's good because you see 2 to power 2, 3 to power 2. How many here I have? 2 to power 3, 3 to power 2. So you don't need to do it again. 2 times, yes? The difference between powers of 2 is 1, 2. So I multiplied this by 2, 72. I have to multiply this by 2. 14 over 72. Okay, 24 has changed to 72. 22 here, 72 here. What is the difference?
3.
A 3 is being multiplied. So I multiply this by 3 as well, which is 15. And then 72 to 72 without any changes, so I keep it like that. And then in principle, let me just do it once. I really want you to do most of these things in your head. You need to write this and then subtract or add these corresponding. So 14 minus 15 is minus 1. Minus 1, minus 1. I don't know. Some of you, I have by experience, some people still think that you are multiplying. It's not. I don't know how to explain, but you have minus 1 here and then minus 1. Okay, so what's the answer?
Minus 2.
Minus 2 over 72. If you stop here, you will lose some points. Because you have to simplify even though it's not mentioned in the problem. Okay, so then you simplify it again, it becomes minus. I myself prefer to put the minus here, it doesn't matter. And then 1 over, this is the simplified version of the problem. Okay, yes please.
If you write, for example, negative 1 divided by 36 or like negative, like, so if you write...
It doesn't matter if you put the negative sign here, here or here.
Your grade doesn't change on a test, for example.
No, no, no. But I prefer to be organized, so it's better to put the minus sign here, but it doesn't matter. Yes. Of course, I put these questions in autocorrection, but I also always manually check it myself. So, for example, if I have given the machine to give you point for this one, if you have written this one, I see it manually and I give you the point. Okay? So you shouldn't be worried about those things. But you need to understand. Okay, so now let us do some of these quickly. Okay, so for example, number 2. So let me just repeat more or less everything here. If some of you haven't understood yet, so let us redo everything, but a little bit faster. So between 34, 51, and 17. If you could do it in your head, much better. Otherwise, you shouldn't be disappointed. So you go and find the factorization of 34. So then the first number that you see is 2. What's the answer? 17, yes? So what should I write here in front of 17, please? Immediately? 17. Because I need something, first of all, prime. I need something that 17 is divisible. But 17 itself is a prime number, okay? So this divisible by 17, it becomes 1. So 34 is nothing except 2 times 17. Yes? And then I go to the next one, 51. Okay, it might be a little bit hard. So 51. Which 51 is not divisible by 2. Is it divisible by 3? By the way, it might be you have studied these before in Grundschule. So is this number divisible by 3? How you can say it immediately? How? This is the rule of thumb. Of course, we can prove it in Math 5, but not now. 5 plus 1 is how much? 6. 6 is divisible by 3. So remember, this will also be divisible by 3. That's the rule of thumb. Divisibility by 3 and 9 are like this. Yes? So 51, you divide by 3. What's the answer?
7.
No, 7 becomes 21. But 17. Yes, it is 17. And then you already know 17. What should I put here? 17. So what is 51? It's 3 times 17. And then if I go to 17, I don't need to do anything. What is 17? 17 is equal to 17. Yes? And then I want to find the greatest common multiple which will serve as the least common denominator. Some books write LCD. Yes? Least common denominator. But this is this one. So I would write 34 and then I will have 51 and then I have 17. Now let me just repeat again. How many prime numbers you see in your list? I see 2 here. I see 3 here. And all of them I have 17. So there are 3 numbers. 2, 3 and 17. So I put 2 times 3 times 17. But I have to choose something for the powers, for the exponents. The highest one that appear. The highest power for 2 is 1. You see in my list there is only 2 here. 2 is only there. And 17 here, power 1, 1, 1. And 3 power 1. So that's it. So 2 times 3 times 17. And what the number is? It is 102. So this is the least common denominator that you have to use. And then you go back there. So the number 13 over 34 minus 7. By the way, what can I write about? Is there any doubt? Minus 7 over 51. I can write plus. Everyone agrees with me?
Yes.
Because I just told you that there is no difference between this number and this number. And you already know that minus a number is equal to the number itself. So first of all, I take this minus sign and put it here. But you see there is a minus sign before that. So that minus will cancel that minus, it becomes positive. So instead of that, if you don't mind, let me write it like this. 51 and then minus 5 over 17. So what should I write? I need to write 102 here, plus 102 here, minus 102 here, and then I start asking questions. So can you tell me, if you divide this by that, how many times? 3, because 2 times 17 is 34, so what is left is 3. So 3 times. So it means 34 has been multiplied by 3. So I have to multiply this by 3 as well. So this becomes 39. And then I ask the same question. 51 is multiplied by what? 2. So I multiply by 2. 17 multiplied by what? Can you tell me immediately? 6. Because 17 and 17 are gone. 2 times 3 is left. And that is 6. And you multiply 6 here. It is minus 30. No, sorry. It is 30. And then you simplify. I think it's better to do it in our head. So I put 102. 39 minus 30 is easier for my brain to calculate this rather than adding this. Order doesn't matter. So this one minus that one is how much? 9. And 9 added to this is 23. But I am sure that this cannot be simplified because 23 is a prime number. End of story. Yes? Is that clear? Okay. But before we go to this more complicated one, there is a reason that I mentioned this one. So let me just write that again. So 13 over 28 and then minus 21 divided by 58 multiplied by minus 29 divided by 35. First of all, if I ask you to write this, what is the structure of this? I hope that you agree with me. This is a number, let me call it x, minus, this is another number, let me call it y, and this is another number, let me call it z. So this is the structure that you see. Yes? It is good to train your eyes to see the structures. The structures, don't let these complications distract you. So, which I have two operations. I need in principle a pair of brackets, but we have a convention. So we know that the priority is with the product. So you need to do this over and over again so it becomes automatic for you. But can you tell me what can I do with these two minus signs? Is there something that I can do? Yes, please.
Make it a multiplication.
Yes, because this is a minus sign, and that's also minus. I'm multiplying two minus numbers, so it becomes what?
Positive.
I can take this away and put this positive. Okay? Now let me ask you a question. If I give you a fraction, you have learned this in your previous studies, and another fraction, if I ask you to multiply them, do you know how to multiply two fractions? Yes?
A times C, B times D.
That is the idea, yes? Not cross. A times C, B times. Okay? So, if you want to do it technically, you should multiply 21 by 29 and you should multiply 58 by 35. It is doable, but I already told you don't use calculator. Then it is not very efficient. If I give you a question and I ask you don't use calculator, I am not crazy to bother you that much for crazy questions. Yes? There's a reason behind that. There is a reason is that if you, by the way, if this number can be simplified with this number, you know that you can take this away. Yes? For example, if you have 6 over 15, what can I do? 6 can be written as 3 times 2 in your head. Of course, this is so simple that you don't spend time on it. You just do it automatically. But then your brain is going through this process. So 3 times 5. And then you see something in common, you can take it away. Yes? But you can immediately say it's 2 over 5. So what I'm saying is that if you can simplify this with this, you can. If you want to simplify this, you can. If you want to simplify this with this, you can. You can simplify this with this, you can. Of course, you can multiply first and then simplify, but it doesn't matter. It is better to simplify and then multiply because the numbers become smaller and then it is better for me to do. So that's what I'm saying. One inefficient way is to multiply this by that, but I see that this and that can be simplified. By what? By 7. This becomes 3, and then this becomes what? 5. Okay? It's much easier. And now this one and that one, I don't know how much are you friend with numbers, think about money, okay? So 58 crowns. How is the relation of 58 crowns and 29 crowns? It's double in size, you immediately realize, okay? So let us use that instinct. So this is 2 times. So it is 1 times if I divide by 29, and this is 2 times. As simple as that. So instead of multiplying 21 by 29, I just need to multiply 3 by 1, which is more manageable. Yes? So what I write, I copy and paste this part. By the way, is this fraction can be simplified? No, 13 is a prime number, so I cannot simplify. So I have to write it down, and I write plus. I have to do the multiplication as before, 3, and I have to write 3. Okay, which one is easier now? Multiplying 21 by 29 and 58 by 35, or just do it like that? So remember, both of them are 100% from mathematical point of view correct. You can multiply. Yes? But for our brain, multiplying 21 and 29 is much harder than multiplying 3 by 1. So remember, it's better to learn to do these problems efficiently. And then, of course, it is inevitable. You have to do some calculations. Now, can you guess the GCM here without doing that long process? Many of students get used to multiply them. They say 280. 280 is 100% correct, but not efficient. I want you to learn the efficient ways. Yes?
You multiply 28 by 5.
5. Why?
Because 8 times 5 equals 40.
Yeah, because already 2 exists here and here. You don't need to repeat it more than necessary. You just need one factor of 2 to be divisible by that and that. Yes? So if you want, so you can say that the number is, well, how much is the number? So if you want, you can write 28. Can you factorize it in your head? You divide by 2, it becomes 14. You divide by 2, it becomes 7. You divide by 7, it becomes 1. Yes? So that is 2 times 2 times 7. And then 10 is what?
2 times 5.
2 times 5. So the least common multiple, how many factors you see? I see only 2. I see 5. I see 7. What is the highest power of 2?
2 to the power.
Yeah, here 2 to power 2, here 2 to power 1. So I have to put this. And that's exactly what you guessed correctly. So this is how much? Can you tell me? 140. Yes? 140. How should I do that? Because everyone knows that I take this 2 and multiply it by 7, it becomes 14. Multiply another 2 by 5, it becomes 10. 10 times 14 is extremely simple, it's 140. So do it whatever you like. And then, now let me just do it quicker. I myself do not write so much. I write 140 here and do the calculations in my head. I divide 140, please listen to this part as well. Divide 140 by 28. What is the answer? 5, because this and that are gone. And then I multiply 5 here. What's the answer? 65, yes? And then 140 divided by 10, 14 times. And then I multiply 14 here is how much? Yes? Yes? And then I add them. So it becomes 107 divided by 140. Yes? So this is the best way I do it. Of course, if you write it separately so much, you see here you have to write the common denominator 3 times. But I just write it 1 time. And I ask myself, what is the division of this by that? I got 5, I multiplied 5 here, then I have a plus sign, I put a plus sign, I did the same process again. This divided by that is 14 times, 14 times that is 42, and then I add. Yes?
In a test, you have to show up like...
It depends. If it is in an A-level question, you get some extra paper to write it down, or if it is E-level question or C-level question, I design them in a way that you just type this number at some paper.
Like in an A-level question, if that is a part of the question,
Mm-hmm.
then do you have to show how you got the answer, or can you just do like 28 times 5?
No, you can do like this. But you cannot, if I give you this and if you just provide the answer, even though the answer is correct, you will lose everything. So you have to demonstrate or illustrate how do you do that. Okay, any questions here? Okay, so let us see. So we solved 3 problems. Those problems, I don't know. Let me solve number 5 as well for you. What do you remember about those dots that I put? It means the pattern continues there. Okay, so what is your opinion about number 5? For momentarily, we will skip number 4 and number 6. Number 6, I will discuss about that even next week. But number 5, can you see what is the answer? So it's a very big list, by the way. Okay, let me review something from yesterday. Can you tell me how many pair of brackets you see in that list? I want to see how many of you understand what was going on. So let me show you here. So this is 1, this is 2, this is 3, it continues until here. If I ask you how many pair of brackets you see, how many of them?
40.
The people who are 40 didn't listen to me.
20. You see, there's 4 there.
No. Because I knew most of
Pair,
you will
hey, you
say...
said pair, so there's 20, right?
No, no, they are going one by one. 10, 11, 12, what is the next one? 13, what's the next one? 14, and it continues to 50. Yes? Tira, you told me correctly, so can you tell me how many of them are there? How many numbers are from 1 starting from 1 to 10?
9.
No 9. If I give you number 1, number 2, and there are students from number 1 up to number 10 in the classroom, how many students are there in the classroom? 10. But if you subtract 10 minus 1, you will get 9, which is not correct. So now tell me, if I start from 10, 11, 12, 13, and I reach to 50, how many numbers are there in my list? 41. Yes? 41. Because you told me 40, you took the difference. 99% is correct, but you lost 1. So let me just write something for you. By the way, so let me, for example, I have 10, 11, and 12. How many numbers are this in this list? 3. But if you take the difference, you get 2, which is not correct. You need to add 1 to that. Yes? So that's the reason. So first of all, how many numbers you see in this list? 41 numbers. And even if you have calculator, typing 41 numbers in the computer is probably a little bit boring again. But our brain can do it fast, very fast. Can you tell me what's the answer and how? Or at least give me the strategy to tackle the problem. In principle, you should be able to answer this in 5 seconds. If you are experienced. If not, in 2 minutes.
41 divided by 2.
I don't know. But what is your strategy?
Solving or finding out what numbers were.
Give me the strategy, because if you find the strategy, everything will be simple. Whenever you have these problems, so you need to discover the patterns. You need to train your brain to be able to catch the patterns as immediately as possible. So what I do if I want to solve this problem, my brain is not capable of solving the whole problem in one go. So I will start thinking about what about the pieces, yes? So I will try to concentrate on one of these pieces, yes?
What I've noticed is if the numerator is always one digit.
Yeah, that's one step to success, yes?
Yes.
Because what you see, 1 plus 1 over 10, immediately in your head, what's the answer? 11 over 10. Why? Because instead of 1, you write 10 over 10. 10 over 10 plus 1 over 10 is 11 over 10, yes? So this becomes 11 over 10. But okay, it's not enough. Don't get disappointed. Go to the next one. What is the other one? It's 12 over 11. Instantly you can realize. Why? Because here, instead of writing 10 over 10, I write 11 over 11. And then when I add, it becomes 12 over 10. 12 over 11. So let me just continue this list. So instead of this one, I can write what? 11 over 10. What is the operation between this if it's not written? Multiplication. Let us put the dot here to emphasize that. And then what happens? 12 over 11. And then what happens for the next one? 13 over 11. Oh, sorry, 12, sorry. And then it continues. Can you guess what happens for the last one?
51.
51 over 50. Okay, so that's a good thing to do. But what's happening now? I want you to see how many of you listen carefully here. If you listen what I said here, in principle you should be able to solve that problem immediately. Because in principle you are multiplying fractions, so you have to multiply all these numbers, multiply all these numbers. But you don't need to, because they have designed the question in a way that alternatively they are cancelling out.
Yeah.
So okay. So from this one, 1 is left, 1 is left, 1 is left. And if I do this, 1 is left, 1 is left here. If I do this cancellation, can you tell me what is the previous one? What is the previous one?
50.
50 over 49, which 50 will cancel that 50. Okay? 49 is being cancelled by the previous one. So what is left is 1 over 10, a bunch of ones, and then what do you have at the end?
51 over
51 over 1. So the answer is 5.1. Yes? So the answer is 5.1. I mean, be careful. You might consider this a hard problem, but I want to tell you, of course, mathematics is hard even for mathematicians. But if you try to learn the patterns and improve this skill in yourself to be able to break down the problem as much as the new problem into smaller pieces. It cannot come overnight. But if you care about it and pay attention, you will probably definitely improve, and I think you will be good at it if you like mathematics. These type of questions, I can bring some of them next week and then try to discuss to see if you like it or not. And then you will see that problems become really, really interesting. Okay. Any questions? Good luck. Thank you.
Instead of one,
Yeah, please.